how to prove trigonometric identities, and I'm going to do two examples, an easier one and a little more complicated one. Watch the first example and then try the second one on your own, and if you're really struggling, then continue watching the video to the end. Okay, so here's the first example we're going to do. We have sine of x cotangent of x equals cosine of x. Okay, I need to, we know that, so the problem is saying that the left-hand side is equal to the right-hand side. Okay, so the left side here is equal to the right side, and we have to prove it. Okay, so what we're doing here is proving that the right side is equal to the left side. Okay, and to do that we need to change sine of x cotangent of x so that it becomes equal to cosine of x, or we need to rewrite cosine of x as this expression over here. To do so, we will need to use some of the identities we already learned about. I'm seeing that on this side over here I have cotangent of x, but on this side I don't have cotangent of x. So what I'm going to do is I'm going to try to rewrite cotangent of x as sine and cosine. I'm going to rewrite it as sine and cosine. So right away I think about the identities I learned, and I think about the quotient identities, right? And the quotient identity says that cotangent of x is equal to cosine of x over sine of x. I'm going to use this identity, I'm going to substitute cotangent of x with this expression over here. So I'm going to say sine of x, and now instead of cotangent of x, I'm going to write cosine of x over sine of x, and then I'm just going to copy the right side. Well, here the sign is multiplication. If I don't see anything, that means I multiply. And I can literally cancel, I can always put a 1 on the bottom here, which I don't need to really. But I can cancel the sine of x because 1 is in the numerator and the other one in the denominator. I have 1 and 1 left over. So I have cosine of x is equal to cosine of x. So I proved that the left side is equal to the right side. Now, I suggest right now that you pause this video, you stop it, and you try to do the second example on your own. If you are really struggling, then please feel free to watch. Okay, now we're going to start the second example. Sine of theta. Theta is just a letter that mathematicians like to use when they talk about angles. I could also say x here, but let's just use theta so that you become comfortable with that Latin letter. Times cotangent of theta plus secant of theta equals cosine of theta plus tangent of theta. Now I want to prove that this side over here is equal to this side over here is equal to this side over here. I see over here cotangent and secant, so my strategy will be to transform the left side. I'm going to take the left side and I'm going to try to transform it and make it equal to the right side. Okay, so I'm going to use some identities to change cotangent and to change secant. Here are the following identities I'm going to use. Quotient identity. I know again that cotangent of theta is equal to cosine of theta over sine of theta. Also for secant, I can use the reciprocal identities. Reciprocal. And I know that secant of theta is equal to 1 over cosine of theta. So I'm going to take this and this over here, and I'm going to substitute it up in the equation I have. So I'm going to say sine of theta, parentheses, instead of cotangent, I'm going to write cosine of theta over sine of theta plus, and this here should go longer, instead of secant of theta, I'm going to write 1 over cosine of theta. Close the parentheses. This side is just going to stay the same right now. Okay, I have parentheses over here and I need to add those two fractions. How do I add fractions? I need the same denominator. So that means that on this side I have to multiply by I need the same denominator. So to get the same denominator, I'm going to multiply sine of theta by cosine of theta. And if I do it to the bottom, I have to do it to the top, cosine of theta. And on this side, to get the same denominator, I have to multiply cosine of theta by sine of theta. Okay, now we're going to continue simplifying this expression inside the parentheses. So sine of theta, and inside the parentheses now I have the same denominator, sine of theta, cosine of theta. And on top I have 2 times cosine of theta multiplied, so it's cosine of theta to the second power. I could write it like this, or I could also just write it like this. Okay, both are valid. Plus sine of theta equals, and I'm going to copy the right hand side. Now, if you notice, I can put a 1 on the bottom, and those are 2 fractions that are being multiplied. So how do we multiply fractions? I have to multiply the tops. Again, this over here is the same as this over here. And multiply the bottoms. 1 times sine of theta times cosine of theta equal to, I copy the right hand side. Now, you can notice we have sine of theta in the numerator and denominator. I can cross it out. Okay, so I'm left with cosine squared theta plus sine theta over cosine theta equals cosine theta plus tangent theta. What I notice here is that I have cosine theta by itself, and if I am able somehow to eliminate one of the cosine thetas and the cosine theta here, I'm gonna get what I want. So I'm gonna do the opposite of adding fractions. I'm gonna take those 2 numbers on top and split them. I'm gonna write them separately over cosine of theta. If you notice, this is almost like if I add fractions, I'm just going to take and write cosine of theta on the bottom and add the top, but now I do exactly the opposite. I split this expression into 2 fractions, and this is perfectly okay for me to do this. I just reverse the process. Now, these cancel out. I have 1. And I also look at this expression and I can remember that this is a quotient identity, because I know the tangent of theta is sine of theta cosine of theta. So this over here is equal to tangent of theta. So you can probably already guess, here I have left 1 cosine theta, or cosine theta to the first power, plus tangent of theta. And I just proved that the original left-hand side and right-hand side were actually equal. Let me know if you guys have questions. I hope this makes sense.